technology is over. So welcome, this is Frank, this is Srinath. And here's a little bit what we aim to achieve today. Srinath.
So, okay, it's a little bit of experiment because we are both going to be doing a talk together. We'll see how it goes.
Yes.
This is not a forecast, right? It's a set of interesting technologies we picked. We'll walk through it. Let's switch to the next slide. Frank, I remember you found this slide and you are very excited.
Absolutely. Yeah. So it was Asanka who sent me a Gartner report, and Gartner had this architecture, the AI supercomputing platform. If you take a look at it, it has nothing to do with AI at all, but it is a very nice platform, and we are highlighting some of the technologies because it's middleware, it's platform, and we thought it would be a good place to start and stimulate discussion over the next days whether we are going to build it. So, and the first thing underlying this is what is called in the literature the computing continuum, right? And the computing continuum is all about the edge, the fog, and the cloud. And the edge is all the IoT devices, actuators, sensors, data collection. Then you have the fog, where you have mid-sized servers, where some computing goes on. And then you have the cloud, where you have supercomputers, large servers, and so on. And what you have, even some quantum computers, right, big ones and small ones, and some things here that are called neuromorphic computers. This is why I go back again. Here you see the different kind of hardware that Gartner says. Gartner says in a few years, you will have tons of different kind of hardware platforms, and we have to hide it. Right, this is the supercomputing platform. So, and the result, if you have this edge, continuum, the result is that you need to shredder your application into different parts and distribute it all over the continuum. Right? That means what we have is different parts of the applications are performed in highly distributed manner on the hardware platform that they are best suited for. And this comes up with a hierarchical distributed heterogeneous computing model, and the continuum, as it's often called, is the platform that realizes this distributed computing.
Yes. So Frank, I think one interesting thing is it's not one computer, many different kind of computers.
Yes.
What does it mean for developers? Because they had to figure out how to handle everything?
If we don't do anything, it will be blood, sweat, and tears. Because the foremost problem to solve is this equation here. You need to split your workload. You need to find out what the devices in the edge, in the fog, and the cloud is. And then you need to find out which latency do you want to tolerate, what costs, what kind of security, your factors, alpha, beta, and gamma. And ideally, automatically you compute everything, and then there is some miracle going on, and all the different parts of the application are distributed, scattered around. Right? And ideally, the programming model allows it to describe the application, and the continuum does the optimal placement. And this is very simple, right? PhD in mathematics, you solve this equation, then you are done, right? But even if the platform can't do it, even if the platform can't determine the optimal workload, the distribution, right? But some smart guy does it in the outside, or a team does it, a lot of problems remain. For example, orchestration capabilities, right? Because you need to integrate the different pieces that you scattered in the continuum around, they need to be integrated. We do integration products. So it's a good idea, right, to do a little bit of marketing and say we're investigating it. You need to deploy the different pieces in very diverse hardware, right? Deployment is an issue. Monitoring is an issue. And this is the continuum platform, right? And everything is highly dynamic because you need to replace, you need to reposition the pieces of code that you have in the continuum, right? It's a very complicated thing that Gartner is coming out. And it has a lot of AI aspects. I only briefly mentioned it because Srinath will discuss the AI aspects in some 10 minutes, right? You have compute-intensive features in AI. They run in the fog, in the mid-size servers, on GPUs, or even on high-performance computers in the cloud. If you need to process private data, think about Apple's private AI, right? You do it on your local device, on the edge. You need to analyze data and so on, right? So even QPUs play a role here because there's something called warm started. QPUs and GPUs act together in order to perform optimal AI. Very complicated stuff.
Okay. So we talk about the continuum,
yep.
Right? So what's neuromorphic computing and how does that fit into the continuum? Is it part of the continuum?
Good question. Yes, neuromorphic is part of the continuum. Neuromorphic has the following origin. I only briefly mentioned it. Most of you know what the von Neumann bottleneck is. The von Neumann bottleneck basically means, you know, for Neumann architecture, you have the memory where you have data and instructions, and you have the CPU where the data are processed according to the instructions. And the instruction and data must be shuffled around between the memory and the processing unit. And the bus is really the bottleneck. You can't speed it up. A lot of intellectual power went into to make that more epic. You know all about caches and so on, right? A lot of software has been invented, but we reach a size of processing power that we need, that the bus really becomes a real bottleneck. And this is why people invented a bio-inspired architecture. Bio-inspired architecture means that companies like Intel are building chips that have neurons, right? They don't have really microprocessors, they have really neurons in the hardware with low energy, because what you have here is the human brain works at 20 watts to solve complicated problem. If you want to do the same on a supercomputer, you need 10 to the power of 8 times more. And these new chips really run at milliwatts, so very energy efficient, right? And so the hardware is really an analogy of the nervous system of the human brain. There are already chips available. Some people can buy them, although they're very expensive. And this is then called neuromorphic computing, because I come to I skip over that. It's analog computing. What you have there is you don't have 0 and 1. You have spikes, right? You have some certain kind of power, and then they integrate the power, whether it's really a 1 or a 0, right? It's a complete, and everything is asynchronous. So it's a very new programming model that is evolving there, right? It's asynchronous based, and there are already some open source frameworks available on GitHub, Lava and Open Neuromorphic. These are the two famous ones, where you can emulate neuromorphic chips on real hardware, right? So you can't run it as energy efficient as it will be when you use these high-end chips, but you can play around with it. And I only mentioned a few applications in robotics, right? There are sample applications for robotics where you process sensor data on the LiDAR, sensory systems, smart devices like wearables are about to be built. AI and ML, right? Because it has neurons on the chips. It's predetermined that you use it for machine learning and some sort of artificial intelligence applications. It has applications, for example, in healthcare, where you process EEG signals to find out what the condition in your brain basically is. Smart prosthetics, right? If you do too much skiing, Rania, right, then you get some problems, and you need at the end prosthetics, and so on. And then the final thing that is new in this Gartner platform is quantum. Quantum, in contrast to neuromorphic computing, is not the same thing on new hardware, right? That you want to do the same thing faster or more energy efficient, but it's all about the ability, you do things that you can't do at all on a classical computer. Right? I mentioned it last time, they can solve exponential problems in polynomial time, so you do completely different things, right? And it is also, believe it or not, energy consumption is much less than the GPU, CPU, or even supercomputer, but these neuromorphic chips have the lowest energy consumption. So quantum computing also has to do with energy. And applications, I guess I mentioned it 2 years ago, is about optimization. Right? Quantum computers are used already today to optimize things that you can't optimize on classical computers. You have portfolio analysis. That's banks in New York and Germany and France are using it for portfolio analysis because it's not faster but much more precise. Drug discovery, healthcare, right, and so on. A lot of applications of quantum. But also this is an integration problem because a quantum computer is not a general purpose computer, it's a special device. That basically means if you want to solve a problem, for example, from machine learning, here I have a part of the whole pipeline, you do some data preparation, right? This is classical code that you need to execute, and only after tons of classical code you dive into a quantum computer to do what a quantum computer can do best, right? Here we do PCA, principal component analysis, and then you do some clustering. At the end, you dive into a quantum computer again, because here is some fast algorithms that are running. It's an integration problem again. We need to integrate classical code and quantum code, and this is what we can do. And in fact, I think Srinath and my team and Srinath's team 3 years ago, we enabled Ballerina to dive into a quantum computer and did the very first prototype, right, if you recall that. So that means the workflow engine integration code need to invoke classical code, need to invoke APIs, interact with cells. That's what we did this time. There are even proposals to extend BPMN, a workflow language, to have special kind of tasks to interact with a quantum computer. And this is our game, right? Workflows, integration, API management, and so on. This is German, I apologize for that, because the hardware vendors did not agree on a single interface, right? You need to have a unified access layer so that you can access the different kind of quantum computers, forget the stuff on top of it, but here we have the API manager. In fact, the prototype that we built is using WSO2's API manager. You need a workflow engine, and this is one part of the AI infrastructure, which is now AI, right?
So Frank, one question to quickly ask is, so these neuromorphic, quantum, they are not really competing, right? They are not,
no.
They need not be winner because they are different aspects.
Absolutely. So a quantum processor is a special kind of machine. A neuromorphic can do similar things than the classical computer, but at a high energy efficient thing. It's some sort of special processor for AI, machine learning, and so on, but it can also do general purpose processing. So they are not competing at all.
Yes, and right? They won't replace normal CPUs either, right?
No, so you won't have a quantum computing cell phone.
Yes.
Anytime soon. Yeah?
At least not anytime soon, right?
Absolutely.
Yes. Okay, so far we were trying to stay at this layer. Now we are going to go up. So I was looking around, I was sending a lot of ideas to Frank. Unfortunately, everything is AI. Nothing left, at least at this moment, most of it. So where we stand on AI, we were discussing, and it's a very interesting question. We had a very interesting way to explain it. So good news is, we have a magical genie or some magical thing that can pretty much
Genie in the bottle. Huh?
Yes, genie in a bottle. That can pretty much do whatever you want. You tell him what to do, it does what you want. Great. Bad news is, that thing has a very funny sense of humor. Because it's once in a while, does some other things too. That's where we are. And so, we are at this point, where we are is that, we see this, we see its power, we see so much thing, but we are not sure exactly how to use it and how effectively use it. We are trying to figure it out. So, as we see, the most pressing issue that people are working on, that we believe play a big role in years to come, is how can we safely bring AI to production. The technologies that can enable AI. So there are there are many topics. There's like how AI and humans can work together, how the outcomes from AI can get feedback and improve, right? How to verify, how to explain. These are a lot of these topics. So we can't cover everything. We'll just go on few.
Yeah.
So now, if you go to the human AI topic, this is, I think, this came, Rania talked about it, we talked about the AI crumple, so on, a lot of these. So it's a key problem. Again, this one has a very, when we talk about this, I remember this analogy of mounted archers. Right? So actually, there was a time, especially Mongol mounted archers were famous. They could ride a horse and shoot, right? Now, okay, when you see it, you don't realize it. But think what you have to do how do you do it, right? You need to, both hands, you shoot. You can't look at where you're going. You are looking at somewhere else, right? You have to keep your eye on the target. You have to shoot, right? But while you do this, right, the horse take care of everything. How does that happen? Right? So one of these ideas being, so how human and AI work together, there are many topics people are looking at. This is one of these analogies being made, which is it should work like a rider and the horse. Hopefully humans are not the horse, the rider.
Absolutely.
Right. But the idea is that can we get to a point where we work with AI, but there are a lot of decisions. Like, for example, if you take that use case, when the mounted archer fights, the horse has to make a lot of decisions, right? It does. So AI will do the same, but still, overall outcome, human will control.
Yes. Hopefully.
Hopefully. Actually, we were arguing now over months whether it will go, Frank, can you talk about it a little bit? Whether it will go completely other way or we will lose the control completely?
My fear is we will lose control.
We'll continue to fight.
So we have fights since weeks. Over weeks.
Yes.
Right. Many people are losing jobs. I'm not as optimistic as Rania, right? Because we humans worked with, we interacted with machines, but these were machines. They had no intelligence, no brain. And now we build machines that nearly have a brain. We have neuromorphic chips. We have intelligence on it. I'm a bit pessimistic. But it will be in 50 years. Many of us will be gone by then. That's okay. The young ones, yeah. Okay.
Okay, so we'll jump to the next one. So again, I think building on the same topic, it's a continuing the argument. So at least for shorter time period. So thing is, if the AI takes over, there won't be SDLC. But at least, luckily, at least for some time, it look like it won't replace it. It'll transform it. What does that mean? So that transform version can be many things. For example, I mean, we are building agent platforms. We already talked about it, right? And it is, I think, very possible. Actually, we were talking a few weeks back that knob tuning, that means any product, it's very possible that you can give the product, give the documentation to the LLM and some AI system, it will tune it. I think that's pretty close. There are very interesting papers already published, which is very close. Probably it will test, not probably, it will figure out how to test. Sorry, I don't know.
Sanjeeva says it's, no, you haven't. Okay.
And sandboxes, etc.
But formal verification? Who is doing the verification?
Oh, sorry. Actually, this is a very interesting use case. This may be a one. This, at least in the way I see it, this very interesting development. If you know David Kapperman, he recently wrote a blog saying, with the AI, formal verification may be the future. So there are these formal programming languages. Actually, we all know this. When we learn about programming, we were taught to write preconditions and postconditions when we write code. None of us do it. That's a different matter, right? So there are these formal programming languages where when you write the code, you can define the pre and post conditions with the code using some annotation. When you do that, compiler can check and tell that given these preconditions and post conditions, this code is correct.
So again, it's not the AI who is doing it.
It is not AI, yes,
okay.
right? So this was around for a long time, actually. For example, for space missions, very mission-critical things, people are doing that. But the problem is, it's very hard to get this code right, because the compiler keeps complaining.
Yeah.
Unfortunately, AI, LLMs doesn't get to complain. So one potential idea, there are papers working on this idea, that you basically ask LLM to generate code, but using these formal languages. Then, using formal verification, we can verify that we can prove, actually, it does what it's supposed to do. Mm-hmm. And if you have code that built that way, you can recompose, and using a theorem prover, you can prove that your code is correct.
But isn't it then more difficult for us developers to make sure that you have the right pre and post conditions?
No, but
I need to formulate in natural language what I want to do. Is your vision that I formulate also my pre and post conditions? In natural language?
Actually, the most recent paper they had done, but this only worked for simple cases, where I can just, on natural language, explain what I want.
Yes.
And it will generate the output, but with the pre and post conditions. Okay. And then, basically, now if it compiles, and if you check the now the developer needs to check the pre and post conditions and make sure it compiles. If it compiles, it's correct. And if you agree with the two, so it may be easier. But of course, now doing this for a simple sort algorithm versus doing it for a very complicated for Rania to use it for the agent platform will take some time.
Yeah.
But
okay.
Yes.
Okay.
So actually, okay, this is a with this way I see it, the way the AI development goes, if you are working in the security, you are the hardest hit. Because what happens is, you have to protect from AI, because people will use AI to hit you with everything. On the other hand, you are supposed to secure the AI too. Right? And to some extent, managing AI's risks somehow come into your way too. Right? So
the issue is now safety.
Yes, sorry.
Security is okay.
The last one, risk management, that is safety. Other two are security. But again, if you are responsible for the security, safety also you have to worry about that too. So let's dig in a little bit. Hang on. Okay. So one side of that is how do you protect the AI, right? So this risk, for example, one part of this is making sure data is correct. The second part is your model doesn't have this risky attack. Actually, they look very scary. So the thing is, when AI look at an image or a video, what it used to identify a human or to act, etc., is not what we see. So there are ways to hack it. I don't know whether you guys remember, there was this protest again, I think, Uber, I forgot against who, but there was a protest again auto-driven taxis,
Yes.
what they did was they took this traffic cone and put it in front on top of the cars. And the auto-driving thing completely helpless because it doesn't understand what the hell going on. It just stuck. It couldn't move. Right? So this is a very different world, this very different kind of attacks. So, I mean, these attacks look like somebody who attacks gets some sticker and go and put it in a highway, and all the auto-driving cars will crash because it will get confused due to that pattern that you don't even understand. Or that I build a pattern, put it in my forehead, and I can walk, I can be invisible in the AI world because AI get very confused and think I'm something else. Right? So, very different world, very scary world. So this one side, we have to figure out how to, and people are trying to figure out how to handle it.
Yes.
And the other thing is, if you are at the side of securing from AI, the static defenses probably won't hold. Right? We need the AI at that side too. When AI fights AI, it's not a fun place to be in.
No.
Oh, we still have 3 minutes.
Huh?
So we still have 3 minutes. We are getting to the last part. So the final interesting topic, I think this came across, I think Yaso talked about measuring agents and monitoring. Rania talks about this. Because with the AI coming up, the observability, analytics, these topics naturally comes up. Right? Because what happens is AI will put the automation on steroids. We will be automating everything. And we cannot guarantee the safety unless we can do the formal thing and completely guarantee safety, then all these problems are gone. But if you can't do that, that means there are a lot of data. Obviously, whatever we do, there will be a lot more data, a lot more automation, right? That means that we have to do a lot of runtime analysis, governance, everything around trying to make it safer. That means that all these data analysis, these technologies will come up. The challenges, the importance both become very interesting.
Okay.
Any parting thoughts, Frank?
Pardon?
We have 2 minutes. Any parting thoughts? Final thoughts?
Final what?
Sorry, final thoughts?
Okay, I'm skeptical about what AI will do with us in a couple of years, right? It's an opportunity from my perspective, right, that we as a product company can build products to include AI as we already do, right? We know how to integrate stuff. We know how to interact with very complicated hardware. We have smart guys in algorithms. So I think we are very good positioned in order to build the products that tie API into the overall enterprise software stacks, right? So in this sense, I'm very optimistic, right? But the future of AI itself, what the relation between human beings and AI will be, that AI agents get identities, will they get a passport finally, right? Yeah, absolutely, huh?
Already people are
marrying AI. Okay. Okay.
So let us hope we are not the host
Absolutely,
and the rider.
let's hope. Yeah. Thank you. Thank you very much.
Thank you.
Thank you.